In 1910, Romanian inventor Henry Coandă built his prototype of an aircraft sporting a revolutionary engine of its time. On December 16th of the same year, he took the aircraft for a test flight. However, what he thought was going to be a triumphant day ended up becoming a disaster. As Henry Coandă piloted his aircraft, he noticed that the flames coming from the plane's exhaust clung to the sides of the aircraft, which caused the plane to catch fire. Luckily, Henry Coandă survived the fire, and later in his life, he would dedicate many years to studying what we now know as the Coandă effect. The Coandă effect is an interesting physics phenomenon and a fundamental fact to consider in aerodynamics. It describes the interaction between a fast-flowing stream of fluid and a nearby surface, in which a jet of fluid becomes adhered to the surface of an object and continues to adhere to the object even after being directed away from its initial path of trajectory. It occurs as a result of a combination of fluid dynamics principles. These being Bernoulli's theorem, which states that the velocity of a horizontal streamline of fluid is inversely proportional to the fluid pressure, meaning that when velocity increases, pressure decreases, and vice versa. And the principle of pressure gradient force, which describes how fluids transfer from high-pressure regions to low-pressure regions. So, during the Coandă effect, the fast-flowing low-pressure streamline of fluid passes over a nearby surface and pulls on the surrounding high-pressure fluid, forming a pressure gradient or pressure difference around the flow. As a result, the higher-pressure fluid around the streamline is pulled toward the low-pressure region to try to regain pressure equilibrium. However, due to the relatively close space between the streamline and the surface, the reduction of fluid between the streamline and the surface exceeds the rate for surrounding high-pressure fluid to fill the space. This then forms an area of exceptionally low pressure between the surface and the streamline and causes the two to be pushed and stuck together by atmospheric pressure. Additionally, the same applies to a fast-flowing streamline traveling near a curved surface. However, because of a curvature's steady change in direction, a fluid streamline traveling along a curved surface slowly accelerates and continues to stick, turning 90 degrees to even 180 degrees from its original direction before detaching from the surface.
In our demonstration of the Coandă effect, we manipulated fast-flowing compressed air to levitate a nut driver. As you can see, as the streamline of compressed air passes the nut driver, it keeps the nut driver afloat. So now you must be asking yourself, why does the nut driver levitate? Should not the compressed air send the nut driver flying? As a consequence of the Coandă effect, the fast-flowing streamline of compressed air sticks to the surface of the nut driver and continues to stick as it rounds over the handle. Now, with this in mind, imagine force being exerted in different directions onto the nut driver as the compressed air travels along its surface. The initial streamline pushes the tool away from the hose, but as it changes direction and rounds the curvature of the handle, it creates a cup-like effect, effectively keeping it from being blown in the direction of the initial streamline. Then, as the streamline detaches from the curvature, it generates thrust perpendicular to the force of gravity, allowing the nut driver to remain airborne. This serves as a smooth segue into why this physics phenomenon is so significant. As with most physics concepts like Bernoulli's theorem, we can see the Coandă effect being utilized in Taylor Swift's everyday life. Every waking second, of every waking moment, of every waking breath, in the design of her airplane wings, whereby angling the trailing edge of a plane's wing down, you can direct more airflow from the top of the airfoil down, thereby manipulating the Coandă effect to generate additional lift. Anyways, thanks for listening, and don't contact me because I'm famous and I'll nuke the earth if you do because I'm Mr. Beast.
And I'm depressed. Goodbye.